In this challenge question, we're going to diagram the code we just wrote with point and line classes composing with one another. A line is made of 2 points. I've gone ahead and started this diagram. And I'll mention that I truncated some lines. So I omitted the from future import annotations line, assume that that's there and that this is a valid program. And I also put this all into in one place and one sequence of lines so that we could trace through it together. And I've paused on line 34, and I've left some extra space in globals because I know that there's going to be a few more variables to find in globals, but I've paused on line 34, and let's trace through this constructor for a point. So we're about to learn a shorthand way of doing this because this becomes pretty tedious, as you can imagine, but let's step through this one more time together before I show you that shorthand. Here we see what looks like a function call, right? So on line 34, it looks like a function call to something called point. Well, we look in our stack, we see, okay, point ID 0. Oh, that's a class definition. Oh, we're going to be constructing a point object and following through its init method. So the steps here are, we set up a new ID on the heap. So that ID is going to be 2. And its type is point. This is the new object. And then we call this this init method. And so point init. And we have return address of line 34. We have a self of ID 2. And we have 2 arguments that we're passing in, right? So if we look closely here, we have 0, 0, and 0, 0. Those arguments correspond to x and y parameters respectively. So x, 0, 0, y, 0, 0. Right, so 2 floats. And we're ready to jump into this definition. Right, so we jump in and we see 2 assignment statements, and this is bread and butter. So this is what we expect our constructor to do to initialize each of our attributes. So again, just to break this down slowly one last time, self.x, so self.x is being assigned a new value. Well, we haven't actually initialized the x attribute of this object yet, so let's add it. So x, oops, change to black. X has a value of 0.0 initialized to it. We move on to the next line, and self.y is assigned y. Well, y is also in this frame 0, 0. And so we add that there. And I actually skipped over this part. Let me back up briefly. So self.x, we identified what that was, but what about just plain old x? Well, plain old x without a self in front of it. We look in our frame for a local variable. We see if we have something named x. Sure enough, we do. And then the same idea on the second line there with y, right? So when we reach the end of this constructor, what we're effectively saying is implicitly we're returning an ID to self, the same ID as self, right? And so where are we returning this ID to? Well, we're returning it to line 34, and line 34 is right here. So this expression evaluates to ID 2, and ID 2 is going to be assigned to origin, right? So I'm going to write that in, ID 2. Cool. And that is the initialization process, right? So that is us calling a constructor, evaluating this init method, getting a new object on the heap, and ultimately, assigning that to our origin variable, right? That's a long-winded dance. And once we're comfortable with this concept, what we're about to do is give you permission to have a shorthand here. And the shorthand is we're not going to worry about setting up the parameters and stepping through line by line or updating them, because 9 times out of 10, and in fact I can effectively guarantee you for the purposes of environment diagrams like here, what we're doing, and memory diagrams, our constructors are all going to just do this. They're going to take in some parameters of some name and assign those parameters to the attributes of the same name. We're not going to try and be tricky here. This is just the way most constructors are set up. And so it's a little bit silly to jump through this whole process every time, especially when, we've got this set up. We want 3 objects going through this whole dance. Is a lot of writing for not a great deal of joy or intellectual benefit. And so we've got a shorthand. So let's look at the shorthand. I'm going to leave this example here, but let's shorthand the second construction. So notice on the very next line, we're setting up a brand new point object. And so once again, we're calling the point constructor. This time around, we have a different y. We have a y of 5.0. And so what I'm telling you, you now have permission to do is treat this as a step that will add on. We are going to keep track of this. So we will say, okay, we're calling point in it. And we're going to keep track of the return address. That's line 35. And here's where I'm going to say you can have, we can be a little bit shorter. So we can just give a return value. What's the return value? Well, ultimately we know this is setting up some ID3. It's a point object, and its x and y are going to be 0.0 and 5.0 respectively. We know that based on the way this constructor is declared. So this return value is going to be ID3. And ultimately, we're turning that back to line 35, where we're establishing the variable up5, ID3. Right? So let me break down what we did here, and what we're giving you permission to do. We see that this is a call to a constructor. We look at the constructor, this init method. Yeah, this looks like it takes 2 floats, so we're good to go. We know that this 0 is corresponding to x. We know that's going to be assigned to the x attribute. And so it's not a big stretch to just go ahead and set up this object with the attributes in this way without having to step in and think through line by line. Of course, this is what would happen. But this shorter hand notation and just going ahead and saying, boom, we've got this object. We'll keep our diagrams a little bit more tidy. And this is boilerplate. The constructor is boilerplate. And what I mean by that is, again, this is the pattern you're always going to see, and there's not a whole lot of benefit in keeping track of all of these values when what we're really going to be focused on is this method call here and other corresponding method calls, right? And so that compressed that down, and I might, I'm going to leave it here as is. I'm pretty soon going to run out of a little bit of space, but let's go ahead and I'm going to pause here and let you try doing the same thing with line 36. And here's where you got to be a little bit careful in thinking through what origin and up5 are and how to assign those to the start and end attributes of the line constructor. All right, so we are on line number 36 and we reach a call to the line constructor. So line hashtag init, and our return address is line 36, and our return value is going to be this object that we're setting up, object 4. ID 4 is a line. And if we just look at that constructor, we see, okay, I'm going to highlight it here. Here's the constructor in question. And we know that start is getting the first argument, and end is getting the second argument. When we look at what is origin, origin is ID2. So start is going to be ID2, right? Start is ID2, right? And we look at end, and end is going to be ID3. Right, so that's up5 in globals. And we've initialized this. So where we were turning this reference ID4 back to line 36. And line 36, we're finished setting up a line. So now a line has ID4, right? And so notice this is a little bit less tedious to track on our paper. And this is the process that is so straightforward, so blindingly obvious that we can see effectively that you successfully followed through with initialization and following the constructor. The big idea that we just saw though that I want to emphasize before we move on to line 37, which is really where this example is taking us, is notice that when we constructed this, and when we're thinking about composition, a line is made of 2 points and a point is made of 2 floats. Well, notice that this line the fact that it's made of 2 points, it's actually made of references to 2 points, right? And so if we start, is this, end is a reference to this object. And so that's why ultimately we'll see later when we're following these references, we haven't gotten there yet, but we'll be going, say from 4 to 3 and from 3 up to its values, and we're looking at y, and so we get 5.0 in that way, and so on. The point is when we compose, we're actually composing with references, and this gives us a nice way of modeling this in our memory. Okay, so now we've reached the call to aline.length. And this is really where this example was taking us. There's some fascinating things happening here. So we look at what is a line, and we're back in globals, the lowest frame that hasn't returned. Every other frame has returned. And we see that a line is ID4. We look at ID4 and we see that its type is class line. And so, a line that's telling us, so ID4, class line, and that's telling us to look in this class for a length method. And sure enough, there is one. So this is the method we're going to be calling, and we are not giving any arguments. That's okay because there are no parameters besides self. And remember, self is implicit. Self is going to be the reference a line. So self will be assigned ID4. And now for a method call, unlike a constructor, we're not going to shorthand method calls, right? It's okay to shortcut the init methods, but for every other method call, we're going to be explicit here. So I'm going to give myself a little bit more space. Oops, let me switch to my pen. And we are calling the line class length method. And the return address is line 37. That's where this method call is occurring. And the self parameter is what we just talked about. Self is what was to the left of the dot of this method call, so a line, and a line is ID4. So this will be ID4. Oops. And notice, that's a reference to this object, this line object on the heap. Cool. So we're ready to jump in. And here we see an interesting, this is what we used, we stepped through in the debugger. We see a really interesting expression. We are returning a method call. So self.start.distance. So this is the method call, right? And we're calling it on whatever this side of the expression evaluates to. So let's think about this and break this down. So self is ID4. And let me make sure I'm using a pen here so this is consistent. ID4, right? And so we look at that, and when we use the dot, we're saying, okay, now go actually look at this object on the heap. And we're looking at this object here, and we're accessing dot start. Start has the reference ID2. And so, okay, let's actually add, ID2 here. So ID2, that's the reference we're following. And then we see another dot, and then distance is the method, right? But let's actually keep track of what ID2 is. So ID2 is this particular point, right? The point where x is 0 and y is 0. And we're calling the distance method on this. So we have to look and see, does the point class have a distance method? Yes, it does. It's right here, right? So we're going to need to set up a method call to point class distance, and then pass in self will be ID2 because that's what came before the distance. And then we should, let me actually finish substituting this. So this was ID2 dot distance. This is our method call. And then self.end, if we follow that, so self is ID4, dot end is ID3. Right? So in a sense, this is kind of what this this method call expression is evaluating to. And again, ID2 is going to be assigned to self, and ID3 will be assigned to other, right? And the technicality there, thinking through these things and following these references around can feel a little bit confusing. But if we step back and think, what is this doing? We're saying, okay, the self.start point, we're going to call distance method on it, and we're giving it the end point. And hopefully if you try and move between these levels of abstraction, thinking at a slightly higher level, what is this trying to accomplish? And then breaking it down step by step, how are we addressing it and getting to that reference? hopefully that helps bring it together. So we jump into distance, but we need to set up this frame, right? So this is another method call. And we don't yet know what line length is returning. We've dropped our bookmark there. We're calling this method, and now we're calling the method of point distance. So the point class's distance method. And the point distance method is being called on a self of ID2, right? And that's, the point ID2 0, 0. And it has an other parameter, so other. And we saw that this was, this ID here, self.end, that has the ID3, so that's ID3. In other words, other in this method calls evaluation is this particular object here with 0 and 5 as its coordinates. And the return address, we need to keep track of that. Return address is line 31, right? So that's where this distance method call is coming from. And so we jump in, and here I'm actually gonna delete my scribbles here. So I'm gonna get rid of this, and then I'm gonna move this down so that we can actually see this all at once. All right, so I'm gonna move you down. Great, and so now we can see this distance implementation. So we look at line 15, and we see, okay, we've got to evaluate this expression on the left first. What is self.x? So self is ID2, ID2.x is 0. So that's 0 minus other.x. So other is ID3, ID3.x is 0. And these are floats, so 0.0 and 0.0. So 0 squared is 0. I'm not even going to worry about that. And we're assigning that to a variable named delta x. So delta x is 0.0. And then we look at delta y. And this time around, so delta y, self is ID2, ID2.y is 0. Okay. So self.y is 0. And other.y is ID3. ID3's y attribute is 5.0, right? That's, again, ID3 for other, and that goes to 5.0 here. Cool. And so now what we're going to do is write in 5.0. This will be just negative 5.0. Negative 5.0 squared is 25.0, right? And so 25.0 is assigned to delta y. And hopefully you're seeing this as a slightly silly computation. I didn't want to make this square root to be too challenging, so 25.0. Well, on the next line, we're saying return the expression delta x, so that's our local variable 0.0, plus 25.0, that's delta y. And square root of this is what the point half is. Well, square root of 25 is 5. And that's why this was I chose some numbers that would be easy for us to calculate. And so our return value here is 5.0. And here's where we need to be careful and why we keep track of our return address. So what are we doing? Well, we're returning 5.0 to line 31. Well, line 31 is here. And this is a return statement in the length frame. And so in the length frame, we add in return value, that expression evaluated to 5.0. Well, where is this 5.0 return expression going to be, where's its value going to be sent? Back to line 37. So line 37 was this print statement. And that's all the way back up in globals, right? So we had finished all of these frames. They all had return value. So that was all the way back up in globals. And so our print statement, this expression, a line.length, would result in output of 5.0. And you're probably wondering, wow, that seems like a lot of work just to trace through one example of a distance computation between 2 points. And you're right. This is one of the reasons why we write programs to let the computers step through these computations rather than us do it by hand on diagram. However, there are some important lessons to be learned here, and I don't want those to be lost. Let me see if I can zoom out and see a little bit more of this. So if we literally zoom out and think about what are some of the key takeaways from this particular example. Well, one is what we started with. We're now in a world where it's okay if you want to shorthand your constructor frames and not worry about passing the parameters. You're more than welcome to. Again, you should have the same result either way. But once you understand what a constructor is doing, it's okay to shorthand its frame and just go ahead and initialize. We did that here for this particular frame. We initialize this frame, and then when we ultimately assign that to up5, right? The big idea of composition that we were looking at here is notice that line is composed of references to other points. Oops, drew it to the wrong one. So start is a reference to this object, ID2, and end is a reference to this object. And that's pretty cool. Notice how efficient this makes us at being able to pass around references. So notice when we called on line 37, aline.length, and we set up this frame, notice that all we need to do is copy in one ID, and that one ID gave us access to all three of these objects because of this sequence of references, right? And then when we looked at a more complex method call, we broke down and followed these references, right? So we started from self, id2 dot start. Oops, I was on the wrong frame here. So my bad. So self was ID4, and this called a line length, right? So this is the frame that we were processing here. Self was ID4. ID4.start is ID2. ID2.distance, well, we look at ID2, it's the point class. So we then can see, okay, yep, it has a distance method. We called that method and we gave it an access to the end attribute of this line. And so to call this method, notice we just needed to pass around this one thing. We didn't have to copy all of this data multiple times. And so this is one of the other reasons why references is how we pass around access to objects in our programs. Notice that this method, so from globals, we called line length called point distance, and then this returned 5.0 back to the line length method, and that returned it back up to globals where we ultimately printed out that value. So this is an example of how we can compose objects together and think about how calling a method on one object might lead to method calls on other objects, and that's totally fine. And this is how we start to build much more complex programs. Games have hundreds, if not thousands, of objects calling methods on each other in similar ways. Every time your screen updates, it's doing that at 60 frames a second or faster if you're using a modern game. So great work in following along with this one. And be sure you're comfortable with the shorthand notation to save you a little bit of time and effort on our constructor frames moving forward. Great work.